All right, so this is number 8 on assignment 61, and it's all the homework you guys have to do tonight, so hopefully you're actually doing it. All right, so as I look at this problem here, I'm going to say, this one kind of makes me want to do the happy dance. And I'm going to do the happy dance because step 1 is done for me. In fact, step 1 is done twice because in both these equations, y is by itself already. So I get to go check-a-rooney. Step 1 is done. So step 2 is to make that substitution. So I'm going to substitute this value for y into this equation right here. So that's going to give me 5x plus 4, and then I go ahead and switch my pens, is equal to 2x plus 7. That ends step 2. Now remember that when we finish step 2, we end up with one equation in only one variable, right? So I have this beautiful equation here after step 2, and I only have one variable in it, and that is x. So that means I can actually solve this equation for x. So I'm going to start, collecting up my like terms here. So I'm going to subtract 2x from both sides of the equation, right? And that gives me 3x plus 4 is equal to 7. I subtract 4 from both sides, right? And I get 3x is equal to 3. I divide everybody by 3, and I get x is equal to 1. So there I am, and that's the end of step 3, because I have now a value for one of my variables. Step 4 is I'm going to go ahead and substitute that into the other equation. So the other equation is y is equal to 5x plus 4. But I know that x is equal to 1, so I'm going to make that substitution. I'm going to say y is equal to 5 times 1 plus 4. Therefore, y is equal to 9, and I have the ordered pair 1, 9. Now I'm going to take that ordered pair and I'm going to put it into the other equation. So let's go ahead and put it into that other equation just to check it, right? And this gives me, the equation is y is equal to 2x plus 7. Well, I know that y is 9. And that is going to be equal to 2 times, and x I said was 1. And then to that, I'm going to finish this off and add 7. Sure enough, that checks. I get 9 is equal to 9. So that's it, guys. That's the whole thing. Like I said, this was an easier one because y was already isolated for me. So I go ahead and plug that step 2. I plug that into the equation. So this is the y that I put in, right? And then it's equal to what I have left. And at the end of step 2, I have exactly what I want. One equation in one variable. I solve that, go through a series of algebraic steps. I get x is equal to 1. That x is equal to 1 gets plugged into the other equation now. I solve for this other variable, and then I check my answer. And that's it, guys. That takes care of the first one. All right, guys, in number 18. So I have the blue equation, y is equal to 1/3 x plus 5, and I have the red equation, x is equal to 3y plus 9. So once again, guys, this one's kind of nice because I have y by itself and x by itself, so I can plug in and solve for either one. In this case, I think I'm going to plug the red into the blue and go ahead and see what happens there. So let's go ahead and grab the blue pen. So I have y is equal to 1/3, and my substitution, right, is right here. So where I have the x, right, I'm going to put this value expression for x since they're equal to one another. So let's go ahead and do that. And that gives us 3y plus 9. So I made my substitution. And now I come over here and I say plus 5. Okay, so that's the end of step 2. And once again, when we look, right, I have at the end of step 2, after I make my initial substitution, I have one equation in only one variable, so I know I can solve it. So let's go ahead and solve this one. So all I'm going to do is to distribute that 1/3. So this gives me y is equal to 1/3 times 3y plus 1/3 times 9 plus 5. So this gives me y is equal to 1/3 times 3/1y plus 1/3 times 9/1 plus 5. And I get y is equal to, well, if I multiply my numerator, right, I get 1/1. So y is equal to y. And I get plus 9/3, right? This here gives me 9/3. Well, 9/3 is 3. So I get y is equal to y plus 8. I collect up my y's, and I get, 0 is equal to 0 plus 8. Well, that is never true. Therefore, I know that this has no solution. Okay, so algebraically, we found it has no solution because we ended with this weird statement that said 0 is equal to 8. So at this point, I'm actually kind of pleased because, you know, I don't have to solve for y because I can't, because there is no value for x. But let's go ahead and take this one step further and see what that means graphically. So I'm going to go ahead and graph my two equations and see what they look like. All right, so here we go. All right, guys, so in this one, we're going to go ahead and graph them and see. Remember, we found that these two equations never intersect, and let's see what happens to these when they never intersect. I get my y-intercept here. This one's already ready to go, right? Y is by itself is equal to 5, and my slope is equal to 1/3. So I'm going to come up here, 1, 2, 3, 4, 5. There's my y-intercept. And then I'm going to go up 1/3. That puts me there. So let's go ahead and... So here's my blue line. There it is in all its beauty. There it is. Okay? And now I'm going to go ahead and take a look at the red one. Well, I need to get y by itself. So the first thing I'm going to do is subtract 9 from both sides of the equation. Right? This is going to give me x minus 9 is equal to 3y. I'm going to divide everybody by 3. And that's going to give me 1/3 x minus 3 is equal to y. Therefore, my y-intercept, right, is -3, and my slope is 1/3. So if I know, I should be able to see right here, right, that they have identical slopes, but they have different y-intercepts. Therefore, these lines should be that P word of parallel. So let's go ahead, right? Same slopes, different y-intercepts. So let's see what happens when we graph the red equation here. So I have a y-intercept of -3, but I have a slope of up 1 and over 3. So there it is. And if I connect these, right, these lines will never meet because they are parallel. Therefore, I know when I have no solution, when I get a weird statement like 0 is equal to 8, my lines never intersect. Therefore, in order to never intersect graphically, these lines must be parallel to each other. I wonder if that's the question I'm going to ask on your quiz tomorrow. All right, guys, I'm done. That's it. I will see you tomorrow when I hand you a quiz. Bye. Here, I'll send you off with some hearts. There you go. Oh, that's a terrible heart. There's a pretty heart. All right, that's it. Bye.